This is the next video in this series, and in this video we are going to cover the datasheet walkthrough of Mifare Ultralight C. Now you don't have to see this video if you have already understood my previous videos and if you have played with the few ultralight tags. So I would advise this video would be good for students of electronics and technologies, so who want to do a coursework or who want to do a kind of a mini project, for example building a loyalty card or a closed loop payment cards or library cards, and this will be a very good exercise. For software developers, if you're integrating your software with NFC, probably is good for you as well. So if you're a teacher or a trainer in technology, example in universities or the training centers, so this video will be helpful for a couple of hours of teaching as well. And when I train in my training center, so this video, this concept of going through the data sheet, okay, it's a compulsory. So we call this as end of the Ultralight C concept. So it's like saying, if you have understood this document on your own, then you are complete. So I'm going to skim through papers one at a time, and we're going to discuss in each page some of the important concept. We're going to ignore something that is not related to the software or programming. Say for example, the electronics that speaks about capacitance or inductance or the timings or voltages or magnetic field or about the die, etc. So we are going to, I'm not going to discuss because I myself don't know more about those concepts. And as we go through page by page, some of the important concept I'm going to show that in the real tag. I'll be using ACR122u, but so I'll be making videos on how to use Ultralight C using OmniKey or PN532 or CR95HF boards, but I will not be covering this datasheet walkthrough in those playlists. So you need a document which you can download from the internet. Now this is the document you have to get from the NXP website, and this is called Mifare Ultralight C contactless ticket IC. So looks like this document was prepared in the year 2014, and in every page I've highlighted some of the important points, and I'm going to give a little bit of explanation about those points. The Ultralight C, so this complies with the part 2 and part 3 of ISO IEC 1443A. So part 2 of this standard is all about the electronics or the magnetic field and the modulation and demodulation, and part 3 is about the anti-collision. So there are some nice documents on internet that explains the part 2 and part 3. Some of the examples of this Ultralight C are like a public transportation, event ticketing, and the loyalty application. Now it also says about the transmission speed of this tag is 106 kilobits per second. So looks like this speed cannot be changed. So unlike like a Mifare Desfire where you can increase the transmission speed, whereas here it's fixed to 106 kilobits per second. So next is the anti-collision. So this card supports anti-collision. Say for example, if you got more than one tag in the field, so only one card at a time will be processed, and so likewise you can communicate with the more than one card. So this is a nice diagram here that explains the Ultralight C tag. This is the actual the processor and the memory, and these are connected to the antenna. If you come across this word PCD, so this is called as a proximity coupling device, which in our case it's a reader writer. So in our case the ACR122u is the PCD. Now some of the features under the security are this tag supports a 3DS authentication. So this has got a 7-byte UID serial number. This has got a 32-bit OTP. We have seen this. And you got read-only locking. This is the static locking. And you also got a locking, the dynamic locking above the memory 512 bit. So the first 512 bit what you see here is same as the ultralight tag. So these are some of the features and benefits. Most of these, they're all we already seen in the previous page. Some of the contents they do repeat, in multiple pages. So I would be, some of the interesting point here is the data retention. So probably now if you're using this in your project, your customer might ask you how long will the data get stored in these Ultralight C tags. So the documentation says it is the 10 years retention time. This is pretty long. So I don't think any card will be still valid for 10 years because technology changes so quickly. So you might end up replacing this Ultralight C with some other, like a Desfire or other tags. So here they explains about again the OTP here. It has got locking and it has a 16-bit one-way counter. So here this is the important point here is the one-way counter. So you can just count, you can just keep on incrementing the counter. And sorry, I didn't highlight this. This is one of the very important point to keep in mind. So how many times you can write to this tag? So here it is 100,000 cycles. So this probably could mean you can write 100,000 times. So after that, you have to provide a replacement for this tag. So here again you got a bit of electronics, which probably now I'm not a good person to speak on this, and probably some of the order information. Again, this may not be useful for us. The block diagram is also, this is an interesting bit here. So this card supports a 3DS authentication. So in other words, it has got a cryptographic algorithm. So the cryptographic operation is done using the hardware. There's a coprocessor called crypto coprocessor, and other things you can see it has a command repeater. So the commands are first sent by the PCD, probably that is processed here, and this is the memory of the of this ultralight tag. So this is again a bit of electronics, which is not of any useful for software developers. So here again is a description about this tag. It says it has got 1536 bit EEPROM, and it also says about some of the features here. It has got a modulator, demodulator, rectifier, clock generator, power on reset, voltage regulator. Again, okay, from my thinking, these are all a kind of a electronic side of the concept, so may not be useful for software developers. So here you can see it has got the 1536 bits are organized as a 48 pages. So we have seen this. Total it has got 48 pages, and each page has got 4 bytes or 32 bits. It also says about the top 80 bits are reserved for manufacturing data, and 32 bits are for a locking mechanism, and 32 bits are for the OTP. So even though it says 32 bits here, I think this 32 bits includes 2 bytes for the static locking and 2 bytes for the dynamic locking. See, this is a very interesting concept here. So this diagram shows how the card is activated, and in general, the entire working of this card. So I've made a couple of videos using a different reader writer board, that's ACR122u board, explaining how a tag gets activated. I'm just going to go in brief. Probably now I will show ultralight tag activating using the various paths. So here the power on reset. So this is where the tag is not powered. So once the tag enters the magnetic field of the antenna, okay, it will get powered and it will be in the idle state. Now the next thing is the PCD, the reader writer, so will keep sending or keep on sending this REQA or WUPA command, and the tag receives this REQA and it replies for REQA and it enters ready state 1. So from ready state you can read the page 0 and come to the active state. So in order to do any read and write operation, the tag must be either in the active state or in the authenticated state, either of this. And all these other states, ready 1, ready 2, these are part of the anti-collision state. So there are a number of ways you can come to the active state. So it can be in the ready 1. Okay, so you can directly read content of page 0, come to active state, or so if the card is in ready 2 state, you can read the ready 2 and come here, or okay, a select command from ready 2. So in the ready 1, the first anti-collision command will take place and the PCD will select this tag in the ready 1 state and the tag will be in ready 2. So in ready 2, one more anti-collision will take place, and after that the PCD will select this tag and the tag is in the active state. So while in the active state, the diagram shows here you can do a write operation or a read 16-byte operation, or you can authenticate and get on to the authenticated state. And while in authenticated state, you are allowed to access all the password protected pages. You can read and write. And keep in mind, while you are in authenticated state, you cannot authenticate again. So if you try to do that, it is taken as a kind of a illegal or a bad command, and it goes, the ultralight tag will go into the halt state. So this is the state of the ultralight. It's like the entire operation of the ultralight tag is driven by the state. So, and there are some important features here, some of the remarks here. So it says any unexpected command, okay, will take the card into this either the idle state or the halt state. Now while you are in the active or authenticated state, you can issue a halt command, or when I say you can, is the PCD can issue the halt command, and it will take the tag to the halt state. So this halt state is very useful when there are more than one tags in the field of the PCD. So when one tag is in the halt state, the PCD can start getting the second tag into the active state. So in order to show you how this anti-collision and selection or activation of Ultralight C works, so I'll be using a different reader board, which is called M24LR Discovery CR95HF board, and I've also made many videos on using this board. But if you want to understand, if you want to know the how the activation or anti-collision works in a ISO 14338 attacks, so I would advise you to look for the playlist called Learn RFID Concepts using CR95HF and ML24 Discovery Kit. And in this playlist, you should look for the video number 6, Understand Activation and Anti-Collision of ISO 14438. So I'm going to show you the anti-collision process using this board now. So you can see here I've connected the CR95HF board, and this is the software, and it's called Understanding RFID using CR95HF version 1.0. So I've already connected that, and I'm going to choose this Mifare Ultralight tag, and we know the top section of the Ultralight tag is same as the ultralight, the same as standard ultralight tag. Okay, so because it's a board, you'll be struggling to hold this Ultralight C tags. One more thing I've noticed about these Ultralight C tags are the antenna that's in this tag are probably not very sensitive when compared to the ultralight tag. That's my observation. So that could be purposefully done by design. So I'm going to place this tag here. So you just have to get used to this. Probably you have to hold it and see where exactly the antenna detects the card. So first thing is I'm going to use the normal. So what I'll be showing is this path. Now as soon as I place the tag on the board, the tag is already in the idle state. It is just waiting for REQA, followed by the first anti-collision, followed by second anti-collision, followed by select command, and the activates. Okay, so sorry, after the first anti-collision there is a select level 1. This is called the select level 1, and the card will be in ready state 2, and the PCD will do the select level 2, and the card will be in active state. So I'm going to hit this active wait, and if you get this error, it is because the tag is not placed well. Yeah, so as you can see here, you just have to get used to this holding the ultralight tag. Look at this, the series of commands. Let's not worry about the top 3 commands. This is very specific to a CR95HF board. So the first command that's gone out of the PCD is the REQA. After that, see, this is the response you get from the Ultralight C tag, and the PCD will issue anti-collision 1. This is the response you get from the tag. The PCD will issue the select 1. This is the response you get. The PCD will issue the anti-collision 2, and this is the response you get, and this is the response you get, and the PCD finally issues select 2 command, and this is the response you get. At the end of the select 2 command, the tag is active. The tag has reached the active state, and I have explained every of these bytes in detail in my other videos. Please, if you're interested to know what's happening, I would advise you to go and see those videos. So once I do that, probably I can start reading here. You can see the first 16 pages are read. So I'm going to show you the next thing, the different route. So this time we are going to see this the ready 1 path, ready 1. So this all starts from REQA, and after that immediately reading the content of page 0. It should be in active state. So I'm going to choose this through ready one. Okay, look at that. So you got this REQA followed by reading the page 0, and now tag is in the active state. How do we know that tag is in the active state? Because if I'm able to read the entire tag, so this proves the tag is in active state. And the next one is about the using the ready to, you are taking from here. So this is the path we are going to take. Go through ready one, and instead of issuing a second anti-collision, you're going to read the page 0. So activate. So after that, if you look at the commands here, the REQA followed by the anti-collision, followed by the select one command, followed by the read address 0. And if you're able to read, so that shows the tag is active. Now, so this software, it's you cannot do anything. As you can see here, I've still not added the Ultralight C functionality. Probably now you're going to see this very soon.